Today, we're going to discuss the top 5 metrics that you should be gathering during your load test of your web application. All right, so some background. What is software load testing? So it is a type of performance testing that simulates real-world user load on your application. For example, you expect your application to support 100,000 users, so you create an environment that's identical to your production environment and put in 100,000 simulated users there, or a mix of simulated and real users. So the goals of load testing may be multiple. Let's list some. First, ensure that the application meets the required performance criteria. For example, 100,000 users. Make sure your app doesn't fall over. Another goal may be that your performance does not degrade after changes. For example, you're releasing a new version and you want to make sure the new version is still performant compared to the previous version. Next, you may have a new feature that may add extra load or different type of load on the application, and you want to run a load test to test it. Next, you just want to run a load test to identify the bottlenecks in your application, right? If you're able to reduce your memory CPU footprint, you may be able to save costs by using cheaper hardware. And third, you may be using chaos engineering experiments, right? And a load test environment is a good environment where you can run these experiments, right? Because you want to do your chaos engineering in a similar environment as your production, but you definitely don't want your chaos engineering experiments to run in production. All right, so load testing can be done manually or automatically, and there's many open source and commercial tools that are available to help you run these load tests. I think the most important feature of such tools is to be able to record and replay user interactions, including simulating unique users and varying the types of traffic that's being sent to your application. And these tools can simulate different user loads. Your users may be classes of users, administrator, shopper, viewer, etc. These tools can help monitor applications performance. Also, you can also do that with kind of a standard infrastructure. For example, AWS has insights that can show you all kinds of metrics. And then thirdly, the software can help you generate reports automatically, right? And if you're not using these tools, you can also get the reports using APIs for your cloud vendor. All right, so let's jump into number 1. Server CPU and memory utilization. You definitely need to track that, right? CPU utilization is the percentage of time the CPU is busy processing instructions. So how loaded that CPU is. Memory utilization is similarly the percentage of memory used by the server. So typically on your web application deployment, you would deploy multiple instances of the same application, and then you have a load balancer that distributes the user requests among them. Let me see if I can do a quick picture here. Let's jump in. Yeah, you have a load balancer, and then you have your instances of your application. You could have 4, whatever, and then traffic comes in from all your users, and then the load balancer decides which server that goes to. All right. If your load is very high, you have a high CPU or memory utilization, that can indicate a bottleneck, right? It may also simply indicate that your application needs to be scaled horizontally, adding more instances, or vertically, basically increase the amount of CPU or memory on each one of your servers. And conversely, if your CPU and memory utilization is low, well, that's great news in terms of you can reduce your hardware to save some costs. So some typical metrics for CPU and memory utilization are CPU utilization below 80% on average, and then memory also below 80% on average. Here's a graph of a recent load test. and you see we are above 80%, not by much. So we know in this case, we know we need some, need some fixes for our application because our load is very high. And we'll want to examine why is it so high. We'll want to take a performance profile, which I'll talk about later in this video. And then our memory is high, and here something happened. Maybe we restarted a server. Maybe we turned off some of the user load, and then in the end we see a spike. I'm not sure if this is real. This is maybe just an error on AWS's part to put the last data point at. I mean, it's even about 100%. So of course your metrics may have issues like this. This looks like nonsense. All right, next one is server errors. So this is probably one of those metrics that is misunderstood and perhaps not used as often as it should be. So I'm talking about server errors. I'm talking about two main things that can happen. First of all, it is your error messages in your application logs, right? Your server's running and it's saying error, timed out, etc., all kinds of errors. It could also be simply looking at the 500 HTTP status codes from your server, which also indicate a server error. Of course, this can indicate that your application can't handle a load, it has a bug. Could also be due to some misconfigurations. So a note about error logs. They're definitely a key debugging tool for developers, right? They can help you identify a root cause of a functional or a performance error and fix it. Right? If someone says like, oh, yesterday I tried doing this thing, it didn't work. Well, you would go and look at your server logs for that period of time. And the first thing you want to do is search for errors during that period of time. So keeping that in mind, when you're writing code in your application, you must use error logs to report actual server errors and not just informational messages like, oops, this data is not what I expected. Like, use your judgment. Is that a real error or not, right? For example, I'll give you an example. A 404, right? Resource not found is typically not a server error, but a client error. User goes to your web page and they go and modify the URL themselves and then, see if there's a resources at that location. Well, the resource doesn't exist, so returns a 404. Now, should the server say it's an error? No, probably not, because putting such client messages into their error log is going to muddy up the error log, and it's going to be harder for you to figure out what is an actual issue and what is just some user-created noise. Client errors such as this, such as 404, should be either logged as informational messages or have kind of some special tag that you can use to exclude this metric from your server errors. Let's take a look at some errors that we recently saw. So here we're using AWS Logs Insights, and you see our filter. So we have JSON errors here, and we're looking for a field called error. We're looking for a field error, or we're looking at a log message that is level error. We're limiting to 10,000. Well, that's the maximum limit here. In this case, we're searching for like the last, maybe the last day or the last hour. And AWS Logs Insights have this nice feature, patterns, right? So your log message is 3,600, huge, but it's reducing down to 26 patterns. So you can focus on the patterns to know what to look for. And here's some example errors. It looks like it's complaining about something. Here, we'll dig into it. And let me zoom out a little bit. Or scroll down. Okay, yeah, I see. Scroll down, scroll over. Yeah, a lot of errors here. And then here, this third one, this is just an example, right? Something about activity webhooks I see down here. So somehow it looks like we're sending a webhook to a bad location. Okay. So the ideal number of server errors is 0. However, in practice, some errors are expected. You could clean it up, but it takes a lot of effort. One specific example I'm talking about is when you have some auto scaling going on, when your application is scaling down the number of servers when there's less traffic, or scaling up, increasing the number of application servers. In those cases, oftentimes during scaling down, you may have like database connection drop or something like that, which may result in error messages. Probably a good idea. Ideally, you'd want to clean those up, but in practice, sometimes it takes a lot of effort to do that. All right, number three, server API latency, also known as response time. So API latency is the time it takes for the server to respond to requests, right? Client sends in a request, server waits, does some work, accesses a database, does some work, and then it sends the response back. And so this average time, is the API latency. And typically, when we're concerned about API latency, the business is concerned about user-facing endpoints, right? The user comes into a site, they want to look something up, they want to log in, they want to check out their basket. And so that time when user clicks the button until they get a response, that is your API latency. And it's a critical metric for user experience because, of course, if the user goes onto a site, tries to log in, you've got a spinner, they're just going to abandon your site in frustration. The standard metric for API latency is 95th percentile, right? That means 95% of the requests are faster than this number. For example, maybe your 95% latency is 500 milliseconds, half a second, pretty decent, pretty long time. And if your 95% latency is higher than that, probably, some users are waiting for like a second or more than that. Okay, so let me give you an example of saying a fail in latency. So here we were running a load test experiment, and we were measuring using Kibana APM tool. We were running this tool. I think we were running this tool in AWS. So latency is fine. It's less than a second, and then we're running an experiment. Spikes up. In this case, it's average, not P95. This dropdown might have P95 as well, which is probably going to be even higher than this, but just looking at the average, it spikes to 20 seconds. This is just unusable here, so big fail on this load test. And the tools, I just mentioned Kibana APM from AWS. There's also OpenTelemetry, some tools around that ecosystem, and there's other vendors providing this kind of tracking and performance tools. All right, let's move on to metric number 4, database slow queries. So first, let's talk about query response time, right? We talked about API response time. So query response time is actually kind of a subset of that, that is specific to the database layer, right? It is the amount of time it takes for the database to respond to a query. And that can indicate that the database is not optimized, or the query is not optimized, or the query needs an index. So these obviously slow queries contribute to API latency, can also contribute to server errors because sometimes you may time out or you may hit a deadlock, which results in a server error. And of course, it can lead to high CPU and memory utilization on the database server itself. So typically what we want to do is we want to look at kind of the queries that contribute the most to the load on the database. So that means we take a query signature. So a query signature is basically a way you differentiate different queries, a simple way to differentiate different queries. And you want to see how often that query signature shows up in your database, and then you multiply that number by your average query response time, and then you sort that list. And so at the top, you should have the queries that have the most impact on your database performance. So once you have that list, you can compare the current load test to some baseline or to a previous load test and see if there's any queries that were added to this list. If you see a new query that showed up in this list, that means it's probably some change or a bug, and you should look into that specific query. So some example from AWS. So AWS got RDS Performance Insights, and it'll show you something like this: loads by weight, AAS. AAS stands for Average Active Sessions. So that's kind of their way of weighing which queries are loading the database. So this is definitely a good list to start from. One thing I don't like is the fact that it limits it to 25, because what I want to do is actually, sometimes I want to search for a query. I want to search for a query. Maybe I improved the query and I want to see, okay, I improved it. Where is it in this list? So it'd be nice to do it. One recent bug I had is actually improve the query by moving most of it to a replica database, and then I didn't see it in the top 25 of the main database. But in reality, I had a bug because I moved all of that query to the other database, which I should not have done. So it'd be really nice if this 25 was adjustable, or I was able to search queries. Now, I probably can do that by going directly to the database and using database native tools, but just something to keep in mind. Okay, let's see. Next and final one is database performance metrics. And of course, I'm cheating a little bit out here because database performance metrics are themselves a group of metrics, but I'm just merging them all together for simplicity. So database performance metrics are CPU utilization, threads running, and IOPS, IO operations per second. So CPU utilization, kind of similar to CPU utilization that we discussed earlier. And so it should also be approximately below 80% on average. Memory utilization, on the other hand, is actually kind of expected to be high for a database, because we expect the database to use as much memory as possible, because what the database is doing when it's using memory is it's caching the data, right? And that cache helps you speed up your queries. Database threads running is the number of connections that are actively processing queries. So if you have a high thread count, a database is clearly under a heavy load. Generally, your database number of threads running should be at or below the number of actual CPUs you have on the database server. So one way to increase the number of threads you can support is to scale up to get a bigger database server. Next is database IO operations per second, IOPS. It is the number of disk read and write operations that the database performs per second. And it should be in line with the database provisions IOPS. So in the cloud, you can get more IOPS. It's one of the things you can, one of the ways you can scale your database. Okay, so to summarize, those were the top 5 metrics you should be gathering. Server CPU and memory utilization, server errors, keep those close to 0 as possible. API latency, keep that low. Database slow queries, keep that predictable. Make sure there's nothing new showing up there. And then database performance. Now there's a few other metrics that we found useful, but we don't include them in the top 5 because they may be situational or don't generally apply. So one is network traffic, the number of bytes sent and received by server. So typically we're talking about the user's request. User request sends the data, and then user receives the data. But in a microservices architecture or in a server where you have third-party integration, your web app server may also be making requests to other servers. So that's another source of network traffic. So user traffic is typically consistent, right? There could be issues, right? You could be sending more data to the user than you expect before, which will load up your network and also contribute to API latency and other metrics. Or say you added a new feature, that feature integrates with a third service, and now there's like a huge amount of traffic going to a third party. So this is just something to keep in mind. Maybe not necessary every load test, but occasionally you want to check your network traffic. Next is performance profiling, right? So many performance tools and programming languages in general can generate a performance profile, which is the time spent in each function of the application. So you can help identify like which function is taking up the most time in the app. So typically you wouldn't, you could do it every time and compare your performance profile from load test to load test. But in reality, you look at your CPU utilization, and if you see it's going high, then you go and dig into that detail by gathering a performance profile. So I'll give you an example of a performance profile that that I did. We're using the Go programming language, so you can represent this flame graph. So I can see, for example, I can see down here that this submit logs endpoint is taking up quite a bit of time. It's like 20%, and then I can dig into it further and say like, oh well, a lot of that is logging, and I see this JSON processing, two case of JSON processing that could be improved. I can look at this and see if that's seems high, potentially another optimization target here. Another optimization target here. So I can kind of look and see and maybe optimize some core functionality. Question why so much logging is happening here. It helps you dig into the details, right? And optimize your application. Next one is database replication lag. So oftentimes you'd want to replicate your database. A replication is one way you can scale your database for high load. And the replication lag is the time it takes for the changes on the main database to be sent over to your replica database. And if you have a high replication log, that means your replica is not keeping up with the primary database, and it can create a bad user experience, or may even create some sort of data corruption, because all of a sudden your data is not consistent. For example, user goes and saves their data, then reloads the page, and the page still has the old data, right? You probably have seen it on some sites, and large replication log is one reason to blame for that. All right, that's it for today.